Good morning, everyone. It is 9:45 Eastern Standard Time, and we're going to start our real-time IoT track. I'm your host for this session, Jeff Wilson, and I run our emerging business initiatives at Esri, and a lot of those emerging businesses you'll see today on these sessions. We're going to get started with Spire, Skyline Technology Solutions, Hawkeye 360, and Airspace Link. And we'll get started here in just a second. And just a quick note that the presenters will be stopping after about 12 or 13 minutes and will be able to answer questions. So please hold all questions to the end. And without further ado, I'm going to turn it over to Mr. Ian Goodridge from Spire to walk you through how Spire is tracking the world's ships, airplanes, and weather from a constellation of small satellites. So over to you, Ian.
Great, thanks, Jeff. Good morning, everybody. As Jeff introduced, I'm going to run through Spire Global real quick, kind of the backbone of the technology, how we do what we do, and then actually get into ArcGIS and show you some of those data points for real. So let me go ahead and actually share my webcam, and I'm supposed to do that so you guys can all see me. All right, cool, great. So let's get into the slides. I have about 6 slides, then I'm going to jump into the demos, and then leave plenty of time for some Q&A as well in the end. Okay, so who is Spire? So real quick, we are a small satellite company. We actually, the slide says 98, but as of about 30 minutes ago, it's actually 100. So big milestone there. We had 2 launched from the space station this morning, early morning. The CubeSat is right here behind me. It's not fake, it's a real background. So there's a real CubeSat there. So if you ever wonder how big they are, you can kind of see comparison to a TV screen behind me there. There's 100 of those in space, and they do many, many things. And what I'm going to show you today is how we bring all that data down, do a whole bunch of processing and calculations, and then deliver it straight into ArcGIS very, very easily. Click to add, and away you go. Talking a little bit more about the data sets we focus on. Our satellites are radio listening satellites, so there's no imagery involved at all. But with that radio listening, we're actually able to develop products that cover the entire spectrum you see on your screen here. Obviously, maritime for ship tracking, aviation for open ocean aircraft tracking, weather forecasting, which is something I'm going to spend a little bit more time on today. The process on how we actually collect that weather forecast data is really interesting and definitely worth a Google later if anybody's curious on the technology. And we're also able to do things with around soil moisture, using again radio signals that bounce off the earth and develop algorithms around how much soil moisture and at what depth. Again, a product that will be coming to ArcGIS, so it could be another layer that you can add very, very easily. And then on the end there, space as a service, we actually do offer that to clients as well. So if any of you out there are, have got a few $1 million hanging around and you want to put a satellite in space, give me a call and we'll give you a quote. So excellent. So AIS tracking, AIS data is not new. Tracking it from space is not particularly new. It actually started on the space station quite a long time ago as a test when they put a unit up there to see if you could pick up the AIS data message that's sent via regular VHF from ship to shore and ship to ship. And it worked, and it was, kind of the beginning of satellite AIS collection. What we've done, and what I think makes a big difference for the ArcGIS community, is even though we're adding the satellite data, so that, these 100 satellites are cruising around collecting all this data out in the open ocean, we're actually merging that with ground-based sources. So we actually have a network of receivers around the world as well that collect the data close to land. That's really good for the high traffic areas. And then we actually have a really interesting service called Dynamic AIS Data, which is, again, satellite-based, but it's actually a very special service that we put together. Basically, there's around about 1,500 or so ships out there, usually large container ships or cargo ships. And when a ship is moving around, it's actually monitoring, obviously, all the AIS traffic around it. And that's a very nice data set because it's high volume, lots of position updates. Obviously, the ship systems are doing a lot to with navigation, and we take that data from those ships and we send that to satellite and then into our services, and that gives us real visibility into some parts of the world that were basically hidden from satellite collection. It's really that sweet spot. So you're too far away from land for ground-based collection, and it's too busy for regular satellites. So other satellite providers would basically be blind to that area, but we've been able to put the system together and actually see into those shipping lanes. So you can see the red on the image there. I'll let that kind of speak for itself. If you've got anybody who's got interest in any of those really highly trafficked areas, through to the Gulf of Mexico, obviously the East China, South China Sea, and through the Gulf and the Persian area there. Definitely worth a look at that data, especially if there's a lot of interest in deep analysis of ship movements. Okay, jumping over to aviation. Those of you who've tracked aircraft using something like FlightAware, Flight Radar 24, obviously are familiar with kind of ground-based ADS-B collection. It's a great radio signal to work with. It's very high volume, very high power, very clean signal, and you can develop very interesting maps or track your flights and things like that. The big issue is when you go out to the open ocean, you lose that visibility on the commercial side. So our satellites can pick up that signal in the open ocean. There's another provider out there that does this as well, but it's just really them and us. So it's kind of nice to have this service coming into ArcGIS. We don't have our entire constellation working on ADS-B collection right now, but we still are collecting a fair amount of data that can be very, very useful for analysis. I'll show you what that looks like again in a second. Okay, plugging away here because I do want to get through the slides and get into the good stuff. Weather forecasting. So a lot of people say, okay, how do you impact weather forecasting using CubeSats? So how does this little guy back here behind me, how does that help you forecast the weather? The process is radio occultation. The image explains it better on the screen there, explains it better than I could do by kind of talking through it. But in a nutshell, we use the GPS signals, the GNSS signals coming from the global constellations that are already out there. As that radio signal comes through the atmosphere, it gets refracted, and that bend of that radio signal we can detect with our CubeSats, because obviously our CubeSats are in low Earth orbit, 500 to 600 kilometers above your head. And by analyzing that bending angle, we can calculate temperature, pressure, and humidity throughout the atmosphere. I mean, you kind of think of it like these slices of data, of this atmospheric data. That's a really valuable data set. We're doing that about 10,000 times a day across the world. And the benefit of that, as you can imagine, is it's everywhere. So we're doing these profiles in parts of the world that have never had that kind of analysis performed, because no one's gone out there and put up a radio balloon, a weather balloon. That would be the alternative to using satellites to do this. We've had a lot of success working with global weather forecasting services, and this is the backbone of our weather forecast. We take this data, mix it all in with all the other weather forecasts that come from the national services, and then create our own weather service. The benefit for everybody, obviously on the call that might be interested, is it's higher accuracy in parts of the world that are more remote. So if you're dealing with people that are open ocean, countries that don't have a lot of weather infrastructure, really can have that high resolution model at pretty much any point on the Earth. It's also coming right into ArcGIS as well. So I actually have a dashboard to show you where we're using a point forecast, where we're looking at a site and we're basically just studying a latitude and longitude. We're just wanting to use that in ArcGIS. Obviously, weather forecasting in ArcGIS is not new. Everybody's probably got many layers of hurricane warnings and rain and things like that. But again, we're offering kind of a unique service around global visibility. Okay, and with a focus on that weather forecasting, if any of you out there are working in particular areas that have a lot of interest in obviously aviation weather, winds aloft, which is basically the winds as you move through flight levels, agriculture and renewable energy and thunderstorm tracking, that would be an area for you to reach out to me, and we can kind of go through the data set. Okay, great. I'm going to stop on the slides because I do want to get into the live demo. Again, my name's Ian Goodrich. My email's on here. I think we're going to be sharing the contact information as well, but please do reach out. I'm pretty active in the ArcGIS community, and happy to connect up. So, okay, I'm going to kill the show here. And hopefully you guys are seeing what I'm seeing, which is kind of an aggregate view of the world shipping. And those of you who are paying attention will notice that this is in a dashboard. So again, we've taken all that technology, all the years of experience of getting those satellites into space to bring all that data down. And basically, we're delivering it into a service that you can just add to any ArcGIS environment, including enterprise, which we actually run here as well internally. So this is a nice way of kind of starting with the shipping, kind of painting that global picture. The aggregate view here is just taking these cells and saying, okay, how many ships are transmitting AIS data in those areas right now? Very quickly, we can just zoom straight in. And once we get down to a certain resolution, we'll turn off the aggregate layer and actually get into individual ships. So I'm just zooming right into just off the coast of Houston here in Galveston. And dots on a map, it's obviously it's AIS data. You can kind of see the vessels moving around. Knowing that a lot of this data is coming via our service and it's coming in basically real time. So here's just a ship called the Special Craft Houston. It's kind of a nice name for looking at Houston, I guess. And as you can see here, it's date stamped from literally a minute ago. So pretty much right when I clicked on it to look at it. So 11/5, 9:54 local. I'm on East Coast time, just in case. Obviously that's a global service. You don't have to work with it globally, but once it's in the ArcGIS infrastructure, it's a real-time feature service, and you can do all the analytics, all the processing, everything you need to do with it. Okay, I'm going to shut this one down. I'm going to work through my tabs here, starting on the left and kind of going all the way through to the right, and then pause for questions at the end. One of the other things we offer in ArcGIS, and we get a lot of questions about, is wow, all this data is coming in, but it's kind of a real-time focus, which is a session of this. But we actually can also do things with analytics. Those of you who use the data stores and things like that, we've built connections to that and built connections that come through to our database. Remembering, we've been collecting data from space since 2007. Our archives of global movements of shipping and aircraft and weather are huge, and we want to expose those. Quickly, what that looks like, I'm just grabbing an example here. I'm just loading it in. So literally, ArcGIS is communicating with our collection of data. It's going to go out, going to zoom off to the port of Singapore here, and it's going to bring back an incident analysis. So I grabbed an hour's worth of AIS data from October 28th, from 5:53 a.m. to 6:53 a.m. local time to me, and I grabbed the track, and literally you can interrogate that data in ArcGIS without any work. So you can see here as I move my slider, I'm loading in that time data so I can interrogate this hour. We call this kind of the incident analysis. We had a lot of people asking to say, hey, what happened here? Can I go back in time and look at that one? The reason I picked this example is we're actually looking at this tug here. There's a tug moving in here on the right-hand side, and it actually was referred to as a close call. It came very close to colliding with another ship there. So that was just an example that someone asked us to work on. Again, built into ArcGIS and absolutely accessible without any work on your side. Okay, closing that one down. Moving into, again, another dashboard. Lot going on this one. Obviously, using some weather data as well, starting to bring weather alongside shipping. What we have going on here is obviously the global AIS shipping map on the left. We have some alerts set up based on weather data. Nothing too far out of the ordinary here. As I scroll around the map, obviously, what's kind of interesting here is I've separated, in this particular view, I've separated out the two WMS layers for weather. So we have significant wave and swell on the top here, and then wind gusts out here, just to kind of keep the map cleaner and then work on it however you wish. But this is literally calling our WMS service and bringing that layer in. And again, it's fully interrogated. You can click on it and actually work with the data there. You can extract variables from it and things like that. What we've actually also got built in here as well, I'm just going to zoom into the port here actually just to highlight that. Zoom into a port of Tampa here just for interest. We've got the dredging lanes, the shipping lanes added. We've got geofencing set up with the port area all running through ArcGIS. And then just to kind of show one of my favorite services is once I zoom into a certain layer, we actually will draw out a ship's dimensions. So when I get to a certain resolution here, it will take this ship and take the dimensions that we're getting from that AIS data message and actually draw out that ship's polygon, and then kind of you can use that in a map for analysis and things like that. You can see that one just it just drew out there. So you can see this little gray box here is the dimensions from the vessel. An AIS message has dimensions in it. from the location from the radio signal, and you can draw that out. Just comes up with a nice bit of kind of real-time awareness for ports and things like that. Let me just do a quick time check with everybody here, and
I think we're up on time there, Ian.
Okay, no problem. All right, so I'm gonna be quiet then. So and stop.
I think folks are gonna chat. Yeah, folks will chat some questions in. We definitely have a hard stop to move along, but yeah, everyone chat questions, and Spire can provide those answers.
Thanks.
Great. All right, thanks, Ian. We're going to move along now to Mr. John Contestable from Skyline Technology Solutions. And Skyline Technology is bringing video feeds uniquely into the ArcGIS ecosystem. And without further ado, I'll turn it over to John. Thanks, John.
Great, Jeff. Thank you. Can you hear me?
We can, yep.
Great. Hi, I'm John Contestable. I'm Director of Public Safety Solutions for Skyline Technology Solutions. I'm excited to talk to you today about our new partnership with Esri and how we might bring streaming video into the ArcGIS environment. We know how important video is to real-time situational awareness, and how ArcGIS is certainly the world's leading platform for spatial awareness. So what we're working on is bringing these two elements together in a more seamless and easy way. And it's important to note at the outset that this is a full API integration between Skyline's video interoperability solution and Esri's ArcGIS system. Personally, I come from an emergency management, public safety, and transportation background. I worked at Maryland Department of Transportation. I've also worked at Johns Hopkins Applied Physics Lab, but I've been with Skyline for over the last year. And I'm more of a practitioner who understands the needs. But we've worked with some of the real smart people here at Esri, Jeff Wilson, who's on the call, as well as Max Payson, to develop this API and leverage our solution. So who is Skyline? We are a full service IT integrator, solutions provider, and product development organization. We're looking to partner with our clients and really bring value to them. We value trust, commitment, and communications, especially in challenging times. And as today during COVID would be an example. Here's kind of a one-page snapshot of who we are. You can see we're not a small company, but we're not a large company either. We have 300 employees. We do work in about 16 states, and we do work across the whole IT stack, if you will, from fiber design and engineering, structured cabling, physical security. We also do a lot of network work, system services. We do applications development. We run a 24/7, 365 network operations center. We host solutions in the cloud. And of course, we're involved in cybersecurity. Who isn't these days? We've also built a lot of fiber. We started out some 15 years ago as a fiber company, and we manage fiber. We run the state of Maryland's government fiber network. We also have installed a lot of cameras, and we manage those cameras, particularly for a lot of DOTs. We do an awful lot of work in the DOT space. And we have a video interoperability solution, which has been in place, where we share video cameras to the public through traveler information type websites, as well as cameras shared to public safety partners like emergency management agencies, next gen 911 type call centers, and the like. So we started working with Maryland Department of Transportation years ago, and that's actually when I first ran into Skyline to help them solve their video interoperability issues. We had Maryland Transit Administration, the State Highway Administration, the Port Administration. They all had different camera systems. We couldn't see one another's cameras. We couldn't share cameras with the Emergency Management Agency or state police. And so we turned to Skyline to help solve that problem. And we basically developed a system in which we can grab any video source in almost any video format, normalize that video stream, restream it to our system, and then serve it up to consumers. And we can serve it up so that it can be easily consumed in a browser, in a web page. It can be seen on your phone or your tablet, as well as at the desktop. So we've basically created a solution, the Swiss Army knife, I like to say, of video interoperability solutions, and been able to solve that challenge. So we like to say it's any camera on any device on any network. We've worked with all the major camera manufacturers, and we've worked with all of their interface requirements, APIs and SDKs, to develop what's necessary to push video forward. Across any network, we started as a network company, and a lot of video streaming is dependent upon network configuration, firewall configuration, and the like. And so we've figured out how to do that, if you will. Any device, as I said, we can serve it up in a number of formats to different form factors. We normalize it generally into H.264 with the ability for multiple sizes and graphic overlays. And what that means is we can tweak the output in terms of bandwidth and frame rate depending upon what the received device is. We can stream these video streams, so we take what can be essentially a unicast type of environment and turn it into multicast. We can manage your cameras in terms of which cameras are shared and to whom they're shared. We can track who has gotten access to those cameras with reports on stream usage. So this is a typical map. We chose Manatee County, Florida, that you're used to seeing, and it's an Esri-based map in which you've overlaid, let's say, shelters and evacuation routes. And then, of course, as emergency managers might do, they might add flood zones and weather radar to this map to be able to see where there might be any kind of problem areas. And then what we've done is we've added traffic cameras to this dashboard. And each one of these squares, these blue squares, represents a traffic camera in Manatee County. And so with Esri's help, we've built a dashboard that we can kind of show this off, if you will. And you're looking at the actual real-time product right now. And this is a dashboard, as many as you've seen. It has the listing of cameras over here to the left, has the map taking center stage in the center, and we stream the video in the top right corner. And the logo, the legend is in the lower right corner. So I'm going to enlarge this a little bit here so you can see what it looks like. Let me close this one out. And I apologize, but I'm up here in Pennsylvania streaming video from Florida, and we're doing it across the WebEx, and so the performance may not be as good as it would be in your environment. But you can see here we are, and you can zoom out on the map, and you can see exactly how many cameras we have in this area. It's quite an extensive collection. And so say you were running an evacuation, say it was during hurricane season, and you're down here in Englewood, and you want to see what's coming at you from a traffic standpoint from the south. So you may click on this, enlarge the camera, and there you go. You can see the image here. We can enlarge this view so you can see the image almost full screen. And looks like it's a pretty nice day in Florida today. Actually, there's one other camera, a couple other cameras I can show you that up here in Minnesota. Mainly, I picked this because it's easy to pick this camera. It's right here without being crowded by a bunch of other cameras. And there you go. What's interesting here too is they blocked out some buildings that they don't want the camera operator to be able to see into, which a lot of camera manufacturers do. And of course, the operator or the tour that it's on is zooming up the road here. One last camera I can show you that's actually a nice shot is up here at Lido Key. Siesta Key. If you wanted to see what traffic was coming in off the bridge, you could choose this camera as an example. And this is a great view. And up here, it looks like a beautiful view. And that's the traffic coming in off of Lido Key. So there you go. I'll get back to the presentation here. So we built this dashboard, and it's up, it's running, it's live, and this is actually only about a month or two old as we've been working on this in near real time. Another example where we're piloting this solution is in Martin County, Florida. This is a view of their tool. It's an ArcGIS dashboard that they're using for their real-time crime center. This is the sheriff's office, and the real estate is similar in that here are their calls for service with the pending calls, active calls, and viewable cameras, and the camera views over here. I have a voiceover. Let me know, Jeff, if you can hear this.
No audio. Oh, can't hear it.
No?
Shown here inside of an Esri dashboard.
There you go. Is that any better?
Solution that is currently being implemented in the Martin County, Florida
Yep,
Sheriff's
we hear that.
Office. Over on the left-hand side of the screen are all lines of calls for service. When calls come in, they go to the top of the screen, and then once they're actually finished with the call, it comes off. Once fully configured, the camera views will filter by where on the map you're looking. So if I was zoomed in right here looking at this call, I would only see the 3 cameras that are in this mapped area. Once all cameras have been ingested into the system, this feature will be fully enabled. Below each camera window, there's a hyperlink that will bring up the
Yeah, it looks like I might have some
full
slow
screen
audio.
tab. Other solutions have failed by relying on connections that are not secure, like the self-signed certificates directly from the camera or flash video. When attempting to view streams like this in a browser, here we're using Chrome, the operator has to manually accept the security risk for each and every camera, refreshing the browser each time. This alone could be a full-time job, not to mention the long
All right, I'm gonna duck out of that presentation. But basically, what it's saying is we developed a streaming protocol called CLSP that is an HTML5 compliant protocol that we use in our solution to basically bring down latency that you might get with other viewers, as well as a replacement for Flash, as many of you know, that was necessary as well. So that is, in essence, our presentation. This is a much larger than necessary photo of myself, as well as a little bit about my bio. But down the bottom here is exactly what we need, is my contact information. And I believe we might have a minute or so for questions, if that's the case, Jeff.
Yes, we got over 2 minutes for questions. So anyone who has questions, please feel free to ask John.
Does Skyline Solutions support video with embedded geospatial metadata? Will it support drone video with KLV data? Yes. The short answer is yes. We've ingested drone video before, and you're really hitting upon the core of what we're trying to do here with Esri. Video is an important component of situational awareness. Anyone who's working in the drone space knows that the drone applications are just going through the roof. And so bringing video into the ArcGIS environment really, we think, combines the best of both worlds, if you will. We've ingested video from drones, from there's body camera footage, there's license plate cameras, there are fixed cameras, there are personal, private, commercial systems. We've ingested video across all of those platforms, dash camera footage from school buses. I mean, we've integrated with pretty much every video system out there and been able to ingest it into our environment. And through the API, whatever we can ingest, we can then push towards the GIS platform and show it both geospatially as well as what the view looks like. And again, it's a real-time streaming protocol. So and the latency is down to seconds. We believe that this partnership is going to be really fruitful for applications in transportation with ITS. We see applications in smart cities. In the past, you've had to build mostly one-off solutions to different manufacturers. Basically, our middleware, hardware, and software can be configured to deal with almost any video input. But again, as I said, we see applications in public safety, emergency management, intelligent transportation, smart cities, as well as different commercial entities who rely on video for security and the like. So we're really excited. we're hopeful that this is going to take off. And if you have any further questions, certainly reach out to me or Jeff. My contact information there below. All right. Thank you, Jeff.
Thank you, John. Great job. Let's see, we're moving on to our next partner now, which is Hawkeye 360, using radio frequency GeoInt to uncover hidden activity. So we're going to pass it over to Mr. Kevin Moyer from Hawkeye 360, and I'll let it go. Hey, Kevin.
Hey, good morning, everybody. Jeff, can you hear me?
Loud and clear.
Awesome. Okay. Now I got to figure out how I share my screen. Can you all see? I apologize. There we go. Now I can do it. Show my screen. Can you all see my screen now?
Roger.
Perfect. Here we go. Okay. So I think we're going to kick off with a quick video showing what our constellation of satellites can do. Jeff, can you play that video?
If we could see radio waves with the naked eye, we'd learn a lot about how we communicate, navigate, and lead our daily lives. But until recently, we've been unable to study this marker of modern life. At Hawkeye 360, we're transforming this unique resource into a new layer of knowledge. Through our pioneering radio frequency analytics, we geolocate or pinpoint radio frequency emissions to illuminate global activity. It starts with our clusters of small satellites flying in triangular formations in low Earth orbit. With satellites, we can detect radio frequency emissions with an incredibly wide field of view, day or night, in any type of weather. Based on customer needs, we tune the software-defined radios to selected radio frequencies in our growing library of signals of interest. As a cluster passes over an area, each satellite observes the signal waveforms. Our satellites then downlink this signal data to a secure cloud environment, where our proprietary algorithms compare the waveform data of all three satellites. We look at tiny differences in waveform properties to confidently geolocate individual signal emissions, and then package signal characteristics and data for rapid delivery to customers. Our customers use this first-of-its-kind geospatial intelligence to reveal what was previously unseen, such as vessels trying to hide, changes in patterns and behavior, and new activity where none should exist. Our customers deepen situational awareness by leveraging our RF analytics to tip and cue other sources as part of a fused multi-intelligence solution. As our constellation continues to grow, revisit rates will drop to about half an hour to give our customers unprecedented access into a new dimension of knowledge that will help them make decisions for a safer world.
Over the past 2 years, we've had our first cluster of 3 satellites on orbit collecting the geolocations that you're seeing here on the screen around the whole planet. These are independently geolocated radio frequency emitters. You can see some use cases around the edge, which we'll get into. These signals can be used to do a lot of different things. In a maritime application, working with our partners Planet and Tanker Trackers, we were able to help fill in a little bit of the story of a fleet of Orion oil tankers moving oil over to Syria. In the recent conflict between India and China, we were able to tip off our partner Planet to go take some imagery based on some signal data we got on the Indian and Chinese border, as you can see there. A couple more examples here of RF signals tipping off folks on to human activity on the ground. And then in the Arctic, a place that often gets ignored, we noticed some radio frequency activity coming out of an island off the north coast of Russia, and it turns out they had reactivated a Soviet-era military base. In Yemen, we saw a whole bunch of what are normally maritime VHF signals, and I'm going to get into this with an Esri story map here in a second. Signals coming out of the middle of the desert, and we're able to figure out that a formerly destroyed radio tower had been reactivated. Quick overview of the company, 5 years old, and raised $140 million to put a constellation of 7 clusters of 3 satellites each on orbit. they will give us a global revisit rate of about half an hour everywhere on the planet, and we can geolocate anything that is a push-to-talk radio, an L-band satellite phone or comms device, or an X or an S-band radar to anywhere within a few hundred meters to sometimes a few kilometers. And that's based on the physics of where the RF energy is coming from on the Earth as it hits the sensors on our satellites that fly in formation, as you saw. Cluster 2, we're excited, is launching this December. It's going to give us a lot more powerful capability on orbit, and we can do a lot more with that. A quick emphasis on the size of the footprint of these satellites. Unlike other satellite-based collection modalities, which are taking really great high-res synthetic aperture radar or electro-optical imagery of a couple hundred square kilometers, we are seeing millions of square kilometers in a single 8-minute pass. So if you want to watch an entire continent or ocean for a certain kind of activity, this diagram here gives you a pretty good idea of how much of the ocean we can monitor within a few minutes. Some examples of the types of emitters we can geolocate there. Again, most emitters over about 5 watts in energy, anywhere between 140 megahertz and 15 gigahertz is within the realm of the possible for our current technology, and that will get better over time as we iterate on our designs of our satellites. Our products are RF Geo, which is a dot and an error ellipse indicating a 95% confidence interval of where we think that emitter was on the Earth. And Mosaic is RF Mosaic is a product that shows a heat map of activity over time to help people understand where there's a lot of activity versus less. And Seeker is a product that leverages AIS and RF to help folks understand where ships are moving around and when they go dark, where they went, as well as, okay, so I'll pause there. I'm gonna flip over to an Esri story map really quick. Can you all see this screen? I'll take that as a yes. So
not yet.
in Yemen,
not yet,
you can't see it. Okay, how do I? There we go. Show my screen. Thank you, Raquel. Can you see this now?
Yes.
Awesome. So as everyone knows, there's been a civil war going on in Yemen for a while. We noticed that there was a lot of signals coming out of this scroll. I'm gonna have to go up here. Over a period of a month last year, we noticed a lot of signals coming out of the middle of the desert. These are VHF maritime signals, which shouldn't be the case in the middle of the desert. But when we went and looked at imagery that was available through our partners, we found that there was most recent photo is a few months old, and the comms tower that was on top of this hill had been destroyed. But clearly, based on the RF activity, we were able to discover somebody had reconstituted that and was using it as a probable repeater tower to talk across a line of hills in the desert. So it's a quick real-world example of RF energy indicating human activity that you might not otherwise know about based on other abilities to collect satellite information. So with that, I would ask Raquel, can you pop up the video of our ArcGIS Pro add-in that we have in development right now? We're pretty excited to show you this. What you're seeing here is a user creating a geofence and time boxing it. So a geospatial and temporal definition of what data they want to look at. And the data will be loaded out of whatever storage place they have the data in that they bought. So they buy the data from Hawkeye, and then they can bring it up in Arc Pro and interrogate it. Unfortunately, my screen is black, so I can't actually see the video, but from what I remember of it, you're about to see them interrogate the various signals as they load, and you're probably watching it load right now. And you'll see what we call a baseball card come up for one of the vessels in that data, and it'll show you some basic information about ownership, name of the ship, and its sanctions status. And then additionally, towards the end of the video, down the bottom, you will see the user show a time bar of signal activity over time to help them analyze and understand when and where signals are happening And that will dynamically recalculate based on where the user zooms to and moves around, so you can see those time bars change. And they're color coded by signal type: X-band radar, L-band satellite phone, VHF radio. And at the very end, you're going to see the user go drill in and see the dark ship path and see the L-band activity over that dark ship, illustrating an instance of potentially somebody talking on a satellite phone while their ship was dark on AIS. And given all the activity you've all seen in the news lately with Chinese fishing vessels coming up against the southern EEZ of the Galapagos Islands, southern border of that EEZ, you can imagine why they might go dark on AIS and why they would still need to be able to communicate with each other.
All right, so thank you, Jeff. I'm Michael Helander, CEO of Airspace Link, and we're building drone highways. And we do that by providing digital infrastructure for pretty much every UAS operation here in the US. It's really hard to fly a drone, whether you're a recreational pilot or Part 107. In the US, there's a lot of rules and regulations. There's if you're 40% of the US is covered in controlled airspace, which requires authorization. There's over 360 different ordinances at different levels of government. And as a pilot trying to understand that, it's complicated. Scaling that to creating beyond visual line of sight for inspection or for package delivery is a complicated and expensive process. It takes months to create safety cases to get those authorization. And GIS is a big solution to supporting that collection for safety cases for the FAA. And then, scaling that is even harder. Starting to get into working with Amazon Prime Air and some of the companies that we're working on logistics is being able to authorize those types of flights at scales. It's extremely complicated, and that's where we come in. We've partnered with the FAA. We've signed a public-private partnership, and in that process, we're one of 5 companies in the US that is allowed to authorize flights for recreational pilots, Part 107, and then also further coordination for flying, say, beyond 400 feet. So we have a system that we've set up in place, and to start to scale that, we have also started building in tools for tomorrow. And let me explain how our system's put together. From left to right, we have products on the marketplace. One is called AirHub for Government, and this allows state and local governments to enter the system, and they upload their authoritative data. And this data is used for creating these corridors and supports safety cases. So when I go to fly through a different community, it's pulling in the schools, the hospitals, the jails, traffic counts, number of lanes that I'm going to fly over. And all of that data goes through our system up into our federal system. And we are calculating the probability based on the type of drone of hurting someone on the ground. And that's used for creating safety cases, but it's also used for recreational pilots, just to understand where they're flying and what's going on. Is there a TFR? Is there a football stadium? Is there a game going on? Our system manages all that, but we provide a tool to the local governments to support those types of operations. And think of it just like building roads. It's a planning tool, and then you have a tool to publish it to our federal system. Second is we have AirHub for pilots. Today we have thousands of pilots. We have 300 businesses using the system. We're currently integrated into 726 airports across the US. So that means when you fly near an airport, our system figures out the flight patterns, understands your ceiling height, how high you can fly, and then we authorize that. And that flight is actually sent to the air traffic control system. And you're logged in the air traffic control system for that amount of time. And our system will communicate back to the drone operators. And we have recreational pilots up to, we're supporting advanced operations with some pretty big retail and logistics companies. And then we provide an API and SDK into the system as well. We have a unique situation with Esri, so we have to make it as simple as possible for users to use our platform. So we do use partner user types, and we use a lot of Esri technology on the back end. So we ended up signing a revenue agreement, rev share with Esri. So no matter the number of pilots or number of government users, we just do a revenue share, because as these flights start to happen, there's transactions per flight, per authorization. There's a fee for that. And there's a fee for managing the infrastructure, just like managing any type of asset. It's just a new type of asset that our system, cloud-based system, and we integrate with the FAA. We have a data exchange with them, and that data is exchanged in real time, all day long, 24/7, of where flights are happening, how often, and so on. So with that, let's get into a demo, because that's the fun part. All right, so our products, AirHub for Government, can be found on the FAA website. Like I said, we're one of 5 companies, and we're the only Esri company providing this service, or at least Esri platform. Anything that you see within the application today can be added to Insights or the Collector app. We provide those APIs, but we provide a front end to make it easy. Products can be found on our website as well. And best of all is in the Esri marketplace. So I can actually just go here, and luckily it's sitting up on the front page. It depends, me as a government user, I use this as a building an asset management system, and I publish it to the pilot app, which is a very different user. So I just want to make that clear. This is an asset management system for managing what's happening on the ground to support advanced operations within my city, county, my government region, my military base, whatever that might be. It helps manage your asset 400 feet and below, 55-pound drones or less. But once you've customers have downloaded this, I'm going to use this area as an example. So we have MDOT, Michigan Department of Transportation, has a login. Wayne County has a login. Probably have been hearing about Wayne County a lot lately. And then the city of Taylor has a login. So it's almost like having federal roads, state, county, and city, and then they can all roll up into each other. And what they're doing is, the first thing we do is we pull in the federal data for that community or county or state to understand what's happening in real time in the air. Where are pilots allowed to fly within our community? Then they pull in all of their GIS data through web services, and our system processes what is the probability of hitting someone on the ground, what are the risks, what are the hazards, what are the risks, and it creates different colors. And again, this is whether GIS department is managing this, economic development is using this, public safety is using this, Parks and Rec is using it. I think I said public safety. Almost every department actually has a login to this platform. It's almost like a transportation planning tool, so that they have a better sense of when they sit across the table with Amazon Prime Air. It helps figure out the best locations. They're able to offer a different type of infrastructure. You have airports, you have highways, you have trains. This area is able to now offer a type of digital drone infrastructure that supports their residents, but also some of the larger manufacturers that are going in here for just-in-time parts delivery. So some of that news will be coming out soon, but right now we're just laying the tracks for those capabilities. It does a lot in here. They're just editing and publishing data. It's tying into their 911 systems. I could go in here and put in, say, we're gonna have a farmer's market. We want to advise drone pilots that there's a farmer's market every Sunday from 10 to 12 o'clock a large gathering of people, there's certain rules and regulations, federal rules and regulations. This helps identify areas to avoid. So when a drone is flying beyond visual line of sight, it's going to get an update that there's something going on the ground. Some other neat things too is this community or county or state can go in and say, well, how often are flights happening in my community? And I can see right here, I ran a quick report, 84, looks like 84 planned flights. 63 of those were approved by the FAA by 11 different pilots during this time period. So they're publishing data out, but they can also get some data back into the system and run some reports about how often it's happening. And that's it. It has nothing to do with flying. It has to do with using data they already use, land use, zoning, and it helps support the drone industry. So now I'm going to switch over as a drone pilot. It looks the same, but it's totally different. So this is a free app that we provide for simple flights, and then there's transactions per complex flight. So this is my own personal account, all my flights that I've logged. This is being integrated with a lot of companies. So example of Esri's drone to map or site scan, they still have to use a system like that to get the flights authorized. They might create the boundaries they're going to fly in, but it still has to go through this system to be approved by the FAA or check for any TFRs or temporary flight restrictions where they're going to fly. And our system is approved by the FAA to do that. So let's see what it looks like if I say I can fly anywhere in the US. We cover the entire US, but we do have 13 states that actually push in their own data to the platform to support these types of operations. So if I go Taylor, Michigan, this is first thing I want to say is I'll figure out where I'm going to fly. I'm going to quickly pull in the federal data so I know some of the restrictions. Looks like I can only fly up to 200 feet through most of the city today. That comes from the federal system. There's some advisories that are happening in the area. And I'm pulling ground risk. There's a button to say fly now, but I'm not going to do that because you'll know where I'm sitting, and it just creates an operation based on where my GPS is of my phone or the computer. I'm going to create new operation, but I want it to be intelligent. I'm not going to fill out any of this information. I do want to fly at 318 feet, but hey, give me the best recommended flight based on what's going on. And just so you know, this process used to take 90 days. I'm just going to say fly from here to here. It's going to calculate the optimized route, I hope. And it's checking air, ground, all of those functions. And this will be the first time I probably had the system sitting too long. But what it's doing is it is looking at, there's a helipad, there's a hospital, it's looking at population density, we're using cell phone data, we're looking at the terrain. We're also looking at, let's see, oops, unable to generate. So I'll just do it manually. So I'm just going to say fly here through here. And then I'm going to hit check the operation for me. Now it would have intelligently flown me around those areas, but I want to also show that it's finding some errors. One, it's going to tell me that I'm asking to fly too high, but we can approve you at 200 feet. You have multiple advisories coming in. No federal advisories, just a 911 call, a golf event, and a farmer's market you're about to fly over. You can contact them, or you can just adjust your flight plan, or just go for it. For advanced operations, if I want to do a package delivery, we start to get into what am I flying over? So we're packaging all that data up from the local government, plus we're enriching the data with multiple data sets to figure out what you're actually flying over. And it creates a safety case report that then is used to take to the FAA for those advanced operations. And this is helping us with some COVID test kit deliveries that will be starting in 2 weeks in a couple select cities throughout the US. We don't fly the drones, we just provide this infrastructure to support that. And then I will finish with, I lost my spot, is let me submit this flight so you can actually see it work. And it's going to the FAA, and it just got approved. And now it is sitting in the air traffic control tower at DTW. There's a flight going to happen at 200 feet for the next hour. And Michael Helander, if there's a change or they resend it, or they can call me, or our system will notify or connect to the drone and shut it down. So there's some a lot of pieces there, but at least you can see it as it works. And a lot more to it, but I'm going to stop there because I think we're getting to the end. The only thing I will like to share is in the federal government, our federal targets, we did propose on a United States Postal Service, ARFI, these capabilities all the way up to DoD capabilities. So it's anyone responsible for drones within their installation, so you can create your own closed system within these installations. So FAA, FBI, Department of Transportation, obviously we're integrated with the FAA today, but there's expansions that can be done as well. So thank you.
Thanks, Michael. There's one question that I think will be relevant to everyone, which is the solution available in FedRAMP boundary?
I would have to have my federal person, and it probably isn't today. It is being moved into it for a project in North Dakota. I just don't know when that will be.
All right. Well, with that, I appreciate that, partners, for taking us through those great demos and overviews. We are going to take a 15-minute break, start back up at 11 a.m. sharp, and we'll have Todd Smith walking us through our AI ML track. So hope everyone's enjoying the show, and we'll see you in 15 minutes.